Okay, now prime numbers. In order to find LCM, we have to understand the concept of prime numbers. Prime numbers are just any numbers in which they have two factors, and those factors are nothing but 1 and the number. For example, if we said 5 is prime number, this means there is no any whole number, two whole number that can be multiplied with each other to get 5. You understand? Other than 5 and 1 itself. For example, let's say you have 5 and 1. You know that 5 times 1 is always 5. Then now you think of another two whole numbers, in which if you multiply them you are going to get 5. Let's say you say 2.5 times 2. So 2.5 is not whole number, and which means there is no any whole numbers that you can multiply and get 5 other than 5 and 1. And this condition makes 5 to be what? A prime number. Let us take 4. 4 can be formed by multiplying 4 and 1. 4 times 1 is 4. But at the same time, 4 can also be formed by multiplying 2 and 2. This means 2 times 2 is 4, and also 4 times 1 is 4, which break our rules, because we said a prime number can only be formed by multiplying 1 and the number. So this one has factors more than 2, and 4 it is not prime number. Let's say we take 6. We know 6 times 1 is 6, but at the same time 2 times 3 is also 6, and which means 6 is not prime number. Now let us take 2. 2 times 1 is 2, and after that there is no another number, so 2 is what? Is a prime number, and on, something like that. So you just have to know that all prime numbers are numbers that they have only two factors, 1 and the number. Example of prime numbers, 2 is the first prime number, which is an even prime number. Then 3, then 5, then 7. After 7, then 11. Don't say 9. We are not talking about odd numbers. Check. 9 is 3 times 3. At the same time, 9 times 1 is also 9. Okay? So we have 13. 15 is not prime number because 5 times 3 is 15. We have 17. We have 19. We have 23, and the rest. These are the examples of prime numbers. I hope you understand. So now, these prime numbers, what do they do? What can we do with it? In which way these prime numbers will help us to identify the LCM of a number? Yes, for sure. They will help us to identify the LCM of a number, because LCM is always the multiple of those factors, but those factors must be factor of a prime number. Okay, I will explain it mathematically. Let us start with the LCM now. Let's say I want to find LCM. In the first example, we are going to find LCM between LCM of 4 and 3. LCM of 4 and 3. Okay, now whenever you want to find LCM of two numbers, all you have to do is to take the first number, write it or express it in terms of its factors. And if possible, prime factors. We always need prime factors. Prime factors are factors of prime numbers. Okay, after that, then you now deduce if there is common number, and if there is not common number, you just take all the numbers. I don't know whether you get what I'm trying to say, but here we go. We just said 4. What's 4 in terms of prime numbers? 4 is nothing but 2 times 2. That is 4. Okay, 2 is prime number, and we have 2 here. Now, how about 3? 3 is just 3 times 1. That's 3. And 3 times 1 is already 3. So, this means we have prime numbers here as the factors. Okay, so in this case, there is no any number in this side which shows up here or repeat. We don't have any repeated number here. Once you have this kind of condition, your LCM is always the multiple of those two numbers. That is this, and this. You just multiply them all. That is your LCM. LCM is equals to 2 times 2, that is the first two numbers, multiplied by the number you have here, which is 3. And 2 times 2 times 3 will give us 12. And this means the LCM is 12. Now, let's see. And like want to find LCM to ask question. Bye. Of 4 and 6. LCM of 4 and 6. Okay. First of all, 4 and 6 in terms of prime numbers. We now know that 4 is 2 times 2, while 6 is 2 times 3. 4 is 2 times 2. 6 is 2 times 3. Okay, as we can see, 2 is repeated here because there is 2 here and there is 2 here. So know that whenever you have repeated numbers, you just have to take just one of the two numbers. Okay, our LCM here is equals to, you will take this one first, 2. Now you said times. In the next numbers we have repetition because we have 2 from this side and another 2 from this side, and we are going to take only one. So we just said times 2, and then we now said times what? Times the last number, which is 3, and 2 times 2 times 3 is 12, and that is our LCM. I hope you understand. Whenever there is repetition of number in both the side, you are going to take only one among those that repeated. I hope you understand. Okay, going to third example. Let's see, we want to find the LCM between LCM of 2 and 5. Okay, LCM of 2 and 5, know that 2 itself is a prime number and 5 itself is also a prime number. So this means the LCM will just be 2 times 5, and that's equals to 10, and 10 is the LCM. And there is one thing you have to know. This 10 must have a factor of the two numbers. For example, 2 can go into 10 without remainder. That's 5 times, and 5 can go into 10 2 times. Okay, another example. Let's say we want to find LCM of 8 and 6. LCM of 8 and 6. Okay, if we are to find LCM of 8 and 6, we'll just say 8. We express 8 in terms of prime numbers. So now we can say that 8 is the same as 2 times 4. First, 2 is prime number, but 4 it is not prime number. Yes, this means we have to break down this one also. So 4 itself is the same as 2 times 2, if you can remember, which means instead of 4 I can simply say 2 and another 2, because 2 times 2 times 2 is 8. Now for the other number, which is 6, we already know that 6 is 2 times 3. Here all the numbers we are having now are what? Are prime numbers. Now our LCM is equals to, we take the first number 2 times, now we take the second number 2 times, but in the third number and the first number in the second, here this one and this, they are common. And I told you that whenever we have common numbers in both the side, we will take only 1. So for these two numbers, we are going to take only 2, like this. Then we now said multiplied by 3, and that is our LCM. So we just simplify. 2 times 2 is 4. 4 times 2 is 8, and then 8 times 3 is 24, and 24 is our LCM. Okay, let's see. We'll take LCM of 10 and 12. LCM of 10 and 12. So now for 10 is 5 and 2. That's 10, because 5 times 2 is 10, and 5 and 2 are all prime numbers. Going to 12. For 12 can be expressed in terms of 4 and 3, but 4 is not prime number, is even, so we have to divide the 4 itself, which means 12 is 2 times 2, because 2 and 2 are 4, and then multiplied by 3. That is 2 times 2, 4. 4 times 3 is 12, while here 5 times 2 is also 10. So from this, our LCM is what? Is 5 times, but this 2 and this 2 are common, so we will just take 1. 2 times, then we now take the next number we have, which is 2, and then times what? Times 3. This is our LCM. So we simplify this, was 5 times 2 times 2 and times 3. So 5 times 2 is 10. 2 times 3 is 6, which means the total answer is 60. So our LCM is 60 here. This is how to find LCM between two numbers. Now, if we want to find LCM between, let's say, more than two numbers, because sometimes we are going to be asked to find LCM between so many numbers. Let's say in this case, we want to find the LCM between 2, 4, and 8. Okay, so what we are going to do is 2 itself is already in prime number. Now 4 can be expressed as 2 and another 2. Also 8 can be expressed as 2 and another 2. So now our LCM is, we now take the first number, which is 2, and then check in the order inside the other numbers if it has common. So in the first number I take 2. I now see that there is 2 here, so I have to cancel it. Yes, because whenever we have two numbers which are common, I told you that you are going to take only one, but still there is another one here, so I'll cancel it also. I take the first one and I'm done with this. Now what left is what is this, the second number in under 4, 2. Now this 2, as we can see, I take it and then I check in the other classes, that is under 8. So this one and this one are common, so I take it, I write it here. And now what left is what is only this one, the last 2, so I multiply it. That is my answer. So I'll just say 2 times 2 times 2, and is equals to 8, which means 8 is the LCM. The only thing is here, you have to know that checking for common number here, it is not only in 2 classes of the numbers, like in class of the first 2 or 4 or 8. It is for the all classes, so you have to check all the class. If there is any common number, you cancel it, you will not take it. Let me give us another example so that we will understand better. Let's say example 6. We have we want to find the LCM between O of 10, 15 and LCM of 10, 15 and 25. LCM of 10, 15 and 25. Okay, first of all we take 10. We now say this 10, it is what in terms of prime numbers, remember it is 2 times 5. Now going to 15. 15, it is 5 and 3. And then we know that there is number 25 also, which it is factors in terms of prime numbers is 5 and 5. 5 times 5 is 25. 5 times 3 is 15. 2 times 5 is 10. Okay, now we just said our LCM is equals to, I have 2 here, then I have to check under 15, do I have 2? No. Under 25, do I have 2? No. Then I write 2 here. Assume that there is 2 under 15 or 2 under 25, I have to cancel it. So now time is, I take the second number 5. Okay, so this 5 is here. Now this 5, do I have 5 under 15? Yes, is the answer, so I will cancel it. I'll just cancel it. because I have already take 5. No repetition. Do I have 5 under 25? Yes. So I'll cancel it. Do you understand? Then I take this 5, this one also. I'm done with it. Then time is, now the next number is 3. Do I have 3 under 10 or 25? I already finished with under 10. So I write 5. And then time is, now what left? Because I take this one also, remain 5. So I have 5. And this is my LCM. Just know that you are going to take all the numbers, but without repetition. In any choose, you will not repeat the way I'm doing it like this. So our LCM will be 5, 2 times 5, and time is 3 times 5 also. 2 times 5 is 10. 3 times 5 is 15, and which means the LCM is 150. Okay, so this is how to find the LCM of any kind of number.